Okay, so this will be mostly review, but we're going to try and tie this into exercise a little bit more. So endocrine system, we're talking about water and electrolyte regulation. Okay, and we're really focusing on the renin-angiotensin-aldosterone system. Okay, and with the renin-angiotensin-aldosterone system, okay, or the RAAS, there's three things that we want to worry about. So blood pressure, urine volume, sodium concentration. Okay, so if you had me for 220, you've seen this flow chart. All right, so just kind of to focus on the important things right here. If I have a decrease in blood pressure, I'm going to release renin. Renin comes from the kidneys. Okay, renin will ultimately cause the activation of angiotensin 2. Okay, renin causes the formation of angiotensin 1, which goes to the lungs, runs into ACE, or angiotensin converting enzyme, and Ang1 becomes Ang2. There are four things that Ang2 does: vasoconstriction, the release of aldosterone, the release of ADH, and it causes you to get thirsty. Okay, vasoconstriction increases pressure. Aldosterone causes us to hold on to salt. If we hold on to salt, we hold on to water. If we hold on to water, pressure increases. Okay, ADH causes us to hold on to water. If we hold on to water, we have more plasma volume, we increase pressure. If I'm thirsty and I act on that thirst, I'm going to have more plasma volume and my pressure is going to go up, right? If you have a balloon, you fill it up with water, there's going to be more pressure in that balloon. Okay, so exercise leads to an increase in blood pressure. Okay, and really what it is, and the way we can do this, there's multiple different ways, right? So if we come back to this formula, mean arterial pressure equals heart rate times stroke volume times resistance. We increase any of these variables, we're going to increase pressure. So by increasing firing rate, we increase heart rate, which increases pressure. We increase venous return, or the amount of blood returning back to the heart. We increase stroke volume, we increase pressure. We increase vasoconstriction, which means we increase resistance. That'll increase pressure as well. Okay, and so this is where the RAAS comes in. So we activate Ang2, right? This is just what we said in the flow chart. So all of these things, or not all of these, but we're really affecting two of those variables. We're affecting resistance by causing vasoconstriction, and we're affecting stroke volume by holding on to salt, which will cause us to hold on to water. And then we're also just holding on to water in general, which will also increase stroke volume. So both of those will, at the very least, maintain, if not increase, blood pressure. Okay, and so then this leads to urine volume. Okay, at rest, if we have high blood pressure, we're going to increase our urine volume. All right, during exercise, though, we increase pressure and our urine volume goes down. So why does this happen? Okay, why does our urine volume go down? Okay, and think about this from a physiological perspective, not, hey, if I'm exercising, I don't want to pee. Okay, yes, that's true, we don't want to. But just in general, this isn't what happens. Okay, and the reason being is that when we increase urine volume, we decrease plasma volume, that decreases mean arterial pressure. All right, and so we don't want that. We don't want to lose fluid while we're exercising. So what we do is we restrict or minimize blood flow to the kidneys, and we also pull as much of that water back out. Okay, going back to the renin-angiotensin-aldosterone system. Okay, and so we need to reduce urine volume. So we've got two ways to do this. And so hopefully you've all heard about this. I know if you've taken my class, you have. But we've got the myogenic mechanism. Okay, so the myogenic mechanism is something that occurs in the kidneys to maintain blood flow. So we don't want it to be too high. We don't want it to be too low. Well, if we increase blood pressure, what happens in the kidneys, specifically in the glomerulus, is that the afferent arteriole, okay, which is the vessel that leads into the glomerulus, will constrict. This reduces blood flow into the glomerulus, which means less blood will get into the nephron, which means less fluid will be converted into urine. Okay? We also release more ADH. Okay? And so that allows us to pull as much water out of the collecting duct as possible. Therefore, we're minimizing the amount of urine that we're producing during exercise. And so the other part that we need to talk about is sodium. Okay, we need sodium to help maintain plasma volume, right? Where there is salt, there is water. Okay, and we also need to maintain sodium concentrations for action potentials and things like that. Okay, so when we have high sodium, we have high plasma volume. Aldosterone, which is part of that renin-angiotensin-aldosterone system, helps causes the release of aldosterone, which causes us to reabsorb sodium. And by reabsorbing the sodium, we're going to be better able to hold on to plasma. Okay, and so our pressure will not decrease. Now, it's important to know that the renin-angiotensin-aldosterone system will be activated during exercise because we set our baroreceptors reset to a higher pressure. Okay, it's kind of like changing the thermostat. You might normally keep your thermostat at 68 in the summer, and so that if it gets to 69, the air conditioner comes on. Well, maybe for whatever reason, you're going to be out of town, you're trying to save money, you're not at the home. Maybe like while you're gone, especially if you have one of these smart thermostats, excuse me, you set the thermostat so it's at 72. Okay, and so now the thermostat, the air conditioning won't turn on until the thermostat gets to 73. Okay, but then when you get back home, everything readjusts, then you can change the settings on your thermostat. So it's kind of like that. That plays a role as well. Okay, ultimately, when we exercise, we need to maintain blood pressure. We do this by holding on to as much water as we can. Problem is, things get a little tricky. You sweat, and when you sweat, you lose plasma volume. And if you lose plasma volume, you're making it more difficult to keep a higher pressure. Okay, not only are you losing fluid, but you're also losing sodium. And sodium makes it a lot easier to hold on to fluid. So if we lose salt as well as fluid, it kind of exacerbates things. And so we're going to do everything, or our body's going to do everything it can to maintain blood pressure.